Welcome back to this series on designing an intertextuality detection algorithm. I know it's been a really long time, but I figured it's about time to get back at it. In this episode, I'm going to talk about testing our code. In the next episode, I'm going to talk about profiling it, which is studying how fast it runs, but testing it is a really important thing to do. It's really important to be sure that your code is doing what you think it's doing. And this is particularly critical as your code gets more and more complex. What we're building is a tool that is relatively complex and it's very easy to return an incorrect answer. So we want to make sure that we're not going to do that. Now, testing code at the fundamental level is basically saying, this is what I expect to see, and then running the code to see if that's what you in fact get. Now you can do this with simple print statements, but fortunately in Python there are a lot of ways that are built in that make this relatively simple. And I'm going to show you how to do this. So if I go into Visual Studio Code, I'm going to start with some very basic examples. So I'll just save this as test.py. We're not going to keep this as part of our code module, but I'll just show you how this kind of works. So let's imagine that I'm writing a function that just adds two numbers together. I'll call it add, and I'll say this is num1 and num2. And I'll simply return num1 plus num2. So I can write a function that tests this with the assert statement. So here I'll say def test add. And now I'm just going to assert that add 2 equals 4. Now, when I run this, if this is in fact correct, it'll pass the test and everything will be fine. But if it doesn't pass this, I know I've done something wrong. Now to run this, I can simply say test add, just like this. And if I go into my terminal and I run python test.py, nothing seems to happen because it has passed the test. Now, I could be a little bit more formal about this. I could say if name equals main, do this. And I would want to do this if I'm building my test directly into my code file. Now, what does this look like if there's a mistake? Well, let's say that I have def molt num1, num2. I'll just be consistent with this. And I'll return num1, num2, except here I've made a mistake. I'm taking the exponent rather than multiplying it. So here I'll go ahead and write a new test, and I'll say def test molt, and I'll assert that molt we'll do 2, 3 equals 6. Because 2 times 3 is 6, but 2 to the third is 8. So I know that this should give me an error. And I'll add this, test molt, just like this. When I run it, now we can see that on line 11 in test molt, we have an assertion error. That means that what I have asserted this to equal is not in fact correct. And that's really all there is to it. But there's actually a library, well, in fact, there are multiple libraries in Python that will make this process a little bit better. So if I import unit test, and I have these definitions, I can actually encapsulate the tests within classes. So if I want to take advantage of all of the functionality that unit tests can offer, I can actually create classes that subclass classes in unit test to really facilitate this. And I'll show you what I mean by this. So for example, I can write a class that tests my multiplication function, and I can say class, and I'll call this test molt, just like this. And then I'll take unit test, and I'll subclass the test case class. Now what I can do is I can, inside of this class, start to write function definitions. So I can write something like test molt, just like this, and I'll give it self. So inside of this test molt function, what I can do is I can run my molt function, and I'll say result equals molt, and again I'll do 2, 3, which should be 6 if this is written correctly. And then I can simply say self.assert equal result, and then 6. I'm just saying this is what this should equal. Now down here, instead of these test functions that I no longer have, all I need to do is I need to run unittest.main. So this lets me take advantage of a lot of extra tools. So when I go back over here to my console and I run this again, now we can see a lot more information. We can see that my test has failed, that there has been an assertion error, and 8 does not equal 6. So now I know that there must be some mistake in my function. So if I go back to the code, I can see, oh, hey, here is a mistake. It's a bug. I delete that, and now if I go back and I run this again, it tells me that it ran the test and nothing failed. Okay? So that's at the very basic level what's going on here. So let's go ahead and write some tests for our functions. Now, as I mentioned before, I can write my tests within the code itself, but that might clutter things up a little bit. I could use a separate file like I have here called test.py, and I could go ahead and import intertext functions. And I can import them and run my tests on them. So this would let me use all of these functions that I wrote in the last episode. That's fine, but also when I distribute this code later, that file will be packaged alongside it. So maybe what I might want to do is I might want to write my tests in a separate directory that doesn't end up getting packaged with the rest of the code. And I think that's what I'm going to do here, okay? So what I can do is I can go into my directory, and I have my intertextuality demo code here that I'm writing for this series. What I can do is I'm going to create a new folder that I'm going to call tests. And this is where I can put all of the tests that will test the various different things that I'm going to be doing. Now inside of this test directory, I will put my test.py file. So what I'll do is I'm just going to go back over here into Intertext, and I'm going to just move this over. So I'll put this back in Intertextuality demo, and I'll move this in to tests. Now, if I want to actually be able to import my intertext functions, it's not going to find it from here. And you can see, in fact, that it already tells me, hey, we have a lint error, we can't find this. I'm going to want to run these tests as a module, so what I'm going to do is I'm going to go ahead and create an empty initialization file for this directory, which will just let Python know that this can be treated as a whole module. And I can close this. And now I just need to import intertext.intertext functions, and this will go ahead and import that. But I want to go ahead and say from intertext functions import all. This way I can just import all of the different functions, and I can start to write tests for them. And this will let me run the code at the level right below this. Now, because Python does have a test module built in, I don't want to call this Python file test. That's not a very good practice. So what I'll do is I'm going to go into my file explorer, and I'm going to change the name and make it a little bit more explicit. And I'll rename this to something like test interfunc, something like this, just to make sure that it's not test. Now, because I have this initialization file right here, what I can do is I can treat this like a module. And so from my root directory, this intertextuality demo folder, if we look at what's going on here, we can see that I have my intertext folder with all of the code, the license, the readme, the setup.py, and then the tests folder. Now, because this is a module, I could say Python with the m flag tests.test interfunc. And when I run it, it goes ahead and it runs that code. All right? So now we're ready to go ahead and start writing tests to assess what's going on in our code. So let's go back to our intertext functions file and see what's going on. Now, if you recall, I wrote a couple different ways of finding these indices, and the one that we're going to end up using in the final product are these three functions here. So we want to be really sure that these ones work properly. So let's start doing that. But we can go ahead and test these other ones as well, just to be sure that we're doing what we think is correct. You can see this is deleted now. So I'll reopen this. And now we have test inner functionality. And I'm going to delete this. And we'll start from a blank slate. Okay, so the first function that I want to test is getSeeds. Now, essentially what's going to happen is I'm going to give it a seed length, and it's going to return to me a list of seeds. That's simple enough. So here, what I'll do is I'll say my class is going to be test get seeds, and this is unit test, and I'm subclassing test case, and I'll call this test seed 4, and I'm going to test I'll call this test seed default. So what I expect to get back from the getSeeds function is a list of seeds, and they are by default will be 4 characters long. So I'm going to go ahead and run the function to get back what it actually outputs, and I'll call this seeds getSeeds, and I'll give it my text, and I'll just say a test. Very short, so it's easy for me to figure out what I should expect. I'll save this. And I'm going to say that my expected is going to equal a list that is ATE, because that's 4 characters long, and then it's going to be space TES, and then it is going to be test. So I think this should be the expected output when there are 4 characters in the seed. So I can say self.assert equal seeds expected, just like this. So if I come over to my terminal, I'm going to clear this off, and I'll run this just like I did before, and it runs the test, and it passes just fine. So that's great. So now I want to be sure that I'm testing things pretty extensively. So I might also want to test changing in. So I'm going to say def test seed 3. And I'll say this is self again, and I'll say seeds equal get seeds, and I'll say test, and this should be, of course, seed length equals 3. And so my expected here is going to be something like AET space TE something like this. And we can go ahead and say self assert equal seeds expected. I'll run this, and we can see that now I have 2 tests, and they both pass. Now, I should be playing around with this a lot to make sure everything ends up working quite well. So this is actually really useful to make sure that it's returning all of the seeds that I expect. So for example, one of the strange things that happens when you write this getSeeds that we talked a little bit about is this length minus seed length minus 1. Because we want to make sure we get all the seeds back, but if we forget to do this minus 1 here, and we rerun this test, it'll actually show us that we're missing it. And it'll be very clear that the second list, which is our expected list, contains an additional element that is not present in the return value. So this is why it becomes extremely useful. So I'm going to go back and I'm going to change that back. Oops. I'll change this back because I know that's correct. And I could write a test for, let's say, the find seeds function. So I'll go ahead and I'll do that. Now, I expect to get out of this a dictionary of seed locations where the seed points to where it occurs in the text. But of course, I need the seeds themselves. So I'm going to go ahead and say seeds, get seeds, a test, just like this. Now, test seeds. Now I would expect that this is going to equal something like A to E. And of course, it's a dictionary that should be 0 because it points to a list of locations. 1 and 2. And I will assert that these are equal to each other. I'll run this, and we can see that this seems to work so far. That's great. But I do want to do my due diligence, and I want to see, well, what happens when there are seeds that appear multiple times? Let's find out. Here we'll say test, test, test. And the expected will look like this. And I have a syntax error here, so let me fix that. Let's run this. So this is an interesting result. We can in fact see that the expected result is not what we get. We can see I asserted that these two dictionaries were equal, and it is good about taking into consideration that the keys aren't always going to be in the same order. But we can see here that in the case where we had a duplicate seed, the seed got input twice when it shouldn't have. So if we look at our original code, what's really interesting about this is showing me a result that I didn't expect. What's going on here is that our seed list does not contain unique seeds. In this particular case, test, if I print seeds here, and I rerun this, what we'll see here is test appears in our seed list twice, okay? And what that means is that when we run our find seed function for seed and seed list, it's going to go ahead and search for the seed again, even if it's already seen it. So if we look at this, the very first item here is test. So in our code, we look for that. We check, is it not -1? If it's not already in our dictionary, we'll go ahead and create a list and save the result. Otherwise, we'll add to it. So this is fine the first time we see it. The behavior is as expected. But the second time we see it, what ends up happening is that it goes ahead and runs the search again, which is not necessary because we're using find and we're finding all of the results. So there are a few ways to fix this. So we could go back into this getSeeds function and change it so it returns only the unique seeds. And there are a few ways we could do this. We could, check if seed not in seeds, just like that. That would be fine. We could also return this as a set, which would make sure that it only contains the unique seeds, or we could simply change the seed list here into unique seeds, and we could say seed list equals set seed list. And I'll just do it right here so it doesn't actually change the functionality of my getSeeds function. Now when I rerun this, we can see that all our tests pass. So that's great. But these functions are not actually the ones that are going to end up in our code, most likely, because they run a little bit slower, and you can see that we're duplicating a little bit of effort when we work with these. So for example, if I look here, we can see a duplication already, right? So when I want to find my seed locations, I first have to get my seeds, and then I have to do this. Now, I can actually do this much more quickly if I index my texts, which I will actually show when we start profiling this. But I want to make sure that our index works properly, right? So I'm going to go ahead and test this. So I'm going to write a class that is test get index. And again, same as before. And so this should actually output the same thing that this find seeds function outputs, but done in a slightly different manner. Because I know that, I can actually, and I know that my find seed function works properly, I could, if I want to, actually compare the two against each other. So I could say expected is going to equal find seeds, a test, and get seeds, just like this. Now, this is not great practice because now I'm scaffolding on the fact that a lot of these other functions are working properly. I could just write this out, but, you know, why not? Self, I'm going to assert that these equal each other, clocs and expected. And I can go ahead and run this. I can see, hey, my getIndex function, at least with the default value, appears to work properly. Now, you'll note that this runs all of my tests every time that I run it. There might be some cases where I want to skip a specific test. So let's say I've decided, well, you know, it's pretty clear that this is working properly. So what I can do is I can go ahead and say unit test dot skip. And I can even give it a reason, already tested. Something like this. So when I run this, now it won't run any of these tests inside that particular module, and it'll tell me it skipped 2 of them. Okay? The reason you can do this is this will really speed things up as your tests get more complicated. You can also skip things internally within a class. So for example, if I wanted to skip this one instead, I could move this here and skip this function. So this is known as a function decorator. It'll also act as a class decorator. When I run this, now it'll just skip that one function. Now, there are a few things that I could do to make this a little bit more streamlined. Let's imagine that in this test get index class, that there are certain things that I'm going to be needing to do every time. So in every different test, something I might want to do is I can have a set up function and I can do certain things. So for example, I could say self.seeds equal get seeds, a test, something like this. So this will create these things for me. And then what I can do here is I can use self.seeds here instead of running this get seeds in every iteration. But I don't necessarily need to do this, but it can help reduce duplication. So you can see that it functions basically exactly the same. So what I'm going to do is I'm going to go ahead and I'm going to write some unit tests just to make sure that everything's behaving how I expect it to behave, to make sure that my code doesn't wind up with unexpected bugs that will give me answers that are not correct. Because remember, this is a library that we're building to support research. And it's really important that it does what we think it does. So I'll go ahead and just test these a little bit more extensively. So you notice this particular failed test where the location of test is 0, but I had said it's 1. This is my fault, right? So when I was writing the test, it's the test that's wrong in this particular case. Of course, this should be at 0 because test is at 0 here, and it is returning a list of our seed indices, right? So in that particular case, my test was incorrect. But that is essentially the long and the short of it. I can fix this, save it, rerun it, and now it works. So that's the basics of testing. And you want to be very robust in how you write these tests when you start writing code that might be used by other people or even used in production. If you want to learn a little bit more about the unit testing framework, the Python documentation has an extensive amount of information on how to use it. It talks about skipping tests and doing things so you're not copying and pasting code, and really it goes through a lot of the details. And of course there are other testing frameworks you can use depending on what your own preferences are. You can also look for information on assertions all over the place, okay? So thank you very much for taking the time to watch this. I hope you found it informative. And in the next video, we're going to talk about profiling these functions. Because remember, the reason I wrote multiple functions here was that some of them are actually a lot faster than others. And we can test this by profiling our code. So I hope you'll join me in the next episode for that. And then after that, we're going to get deeper into the logic of building this intertextuality library. And eventually, we'll push this out to the public and everybody can use it. All right? Thanks again, and I'll see you soon. Bye.